and welcome back to our YouTube channel. I am thrilled to share that we have reached a significant milestone on our channel. We have uploaded a series of 16 videos covering the IUPAC naming of organic compounds from the most fundamental to the advanced level. If you haven't watched them yet, make sure to check out our playlist and catch up on all the exciting content we have covered so far. Today, we will dive into the exciting world of problem solving, tackling some IUPAC naming examples straight from your class 10th SSC Board Telangana Physical Science textbook. So buckle up and get ready for a brain teasing session. In this video, we will explore example problems from your class 10th SSC Board Telangana textbook, and in our next video, we will be delving into some more IUPAC naming problems, this time from the exercises in the textbook. So grab your pens and notebooks and let us put our IUPAC naming skills to the test. Before delving into problems, let us recap of the IUPAC naming structure. I already explained it in some of our previous videos. Now let us have a quick recap of the same. The IUPAC naming of an organic compound consists of three parts, namely root word, prefix, and suffix. The root word represents the largest continuous chain of carbon atoms known as parent chain. It provides the basic name for the compound. Next, prefix. The prefix is used to indicate the presence of substituents or secondary grade functional groups in the molecule. Next, suffix. The suffix indicates the type of functional group present in the compound. It is added after the root word and reflects the functional group's nature. Prefix again has two parts, primary prefix and secondary prefix. Root word, it represents the continuous longest carbon chain. Depending upon the number of carbon atoms present in the continuous longest carbon chain, the base name of the compound is represented. Next, suffix also has two parts, primary suffix and secondary suffix. On whole, there are 11 parts in the IUPAC naming structure. Let us explore one by one. Number, numerical designation. Next, halide or alkyl or secondary grade functional groups. Next, only for cyclic compound. The primary prefix will come only for cyclic compound. Next, number of carbon atoms. Primary prefix also has three parts, number, numerical designation, nature of saturation. Secondary suffix also has three parts, number, numerical designation, and functional group. Let us explore one by one. Number. Number is nothing but number prefix. This tells about to which carbon atom of the compound the substituents or secondary grade functional groups are attached to. Okay. Next, numerical designation. It is also called numerical prefix. When the same substituent or secondary grade functional group is repeated twice, thrice, etc., it is denoted by di, tri, tetra, etc. Next, secondary prefix. Secondary prefix is nothing but secondary grade functional groups or substituents. Okay, This tells about the second grade functional groups known as substituents. For example, halogens, you see here, halides, fluoro, chloro, bromo, iodo. Next, alkyl groups, CH3, methyl, C2H5, ethyl, propyl. When one hydrogen atom is removed, we get the groups called alkyl groups. When one hydrogen atom is removed from alkanes, we get alkyl groups. Okay. Next, secondary grade functional groups: nitro, nitroso, alkoxy, hydroxy, amino, formyl, etc. Okay. The secondary grade functional groups are nothing but, for example, if a compound has more than one functional group, at that time only one functional group will be taken as the principal functional group according to the seniority table, and the remaining functional groups will be considered as the secondary grade functional groups. They will be prefixed. Okay. Next, primary prefix. It is used only for cyclic compounds. Okay. And if the compounds are not cyclic, this part of the name is absent. Okay. The primary prefix is only one, that is cyclo only. It is used only for cyclic, alicyclic compounds or cyclic compounds. Okay. Next, root word. Depending upon the number of carbon atoms in the continuous longest carbon chain, the root word is derived. If the parent chain contains only one carbon atom, the root word is meth. Two carbon atoms, if it contains it, the root word is eth. Three carbon atoms means prop, but, pent, etc. Okay. Next, primary suffix. Again, numbers. In this case, primary suffix, number is nothing but number prefix. It denotes to which carbon atom the multiple bonds are attached to. Next, numerical designation. If a compound contains more than one double bond or triple bond, at that time numerical designations are used. If two double bonds are there or triple bonds are there, at that time di, tri, tetra, etc. Nature of saturation. In the parent chain, what type of bonds exist? Depending upon that, primary suffix is named. If only carbon-carbon single bonds are there, at that time the primary suffix is ane. If at least one carbon-carbon double bond is present in the parent chain, the primary suffix is ene. If at least one carbon-carbon triple bond is present in the parent chain we selected, that is, the primary suffix is ine. Okay. Next, in secondary suffix also we have number, numerical designation and functional groups. See here, number again represents to which carbon atom in the parent chain the functional group is attached to. It will represent that. Numerical designation. If more than one functional group is attached, at that time, if two functional groups are there, same functional groups are there, at that time di. If three functional groups, same functional groups are attached three times, at that time we get a numerical designation tri, etc. Okay. Next, functional group. These are the functional group. If compound contains only carbon and hydrogen atoms, then the functional group is E. Okay. If alcohols are there, OH functional group is there, the functional group name is alcohol and the secondary suffix is ol. If CHO functional group is there, the secondary suffix is all, like this. Okay, so this is all about the IUPAC naming structure. Now let us look at the functional groups which are shown as the secondary suffixes. Suffixes added after the primary suffix to indicate the presence of a particular functional group in the carbon chain are known as secondary suffixes. Here you can see the names of the functional groups and their secondary suffixes. Functional group name and secondary suffix we used here. I am showing alcohol. The name of the functional group is alcohol, OH. Secondary suffix used for alcohols is ol, OL. Aldehyde, CHO functional group, and secondary suffix used for aldehydes is al, AL. Next, ketone, one. Carboxylic acids, COOH functional group. Secondary suffix used for it is oic acid. Sulfonic acid, SO3H. Secondary suffix is sulfonic acid itself. Amine, thioalcohol, thiol. Cyanide, nitrile. Ester, COOR, O8. Amide, CONH2, amide. Secondary suffix is amide. Acid halide, COX, OL halide. Okay, so these are the some functional groups and their secondary suffixes. When a compound contains more than one functional group, at that time one of them is chosen as the principal functional group. The selection of the principal functional group is based on the seniority table given below. So the table is arranged highest priority to lowest priority. See here, group, name of the group, prefix name, suffix name. SO3H, name of the functional group is SO3H. If it is used as prefix, the name of the prefix is sulfo. If this group is chosen as the principal functional group, at that time the suffix name is sulfonic acid. Next, COOH. If it is used as a prefix, at that time the prefix name is carboxy. Next, suffix name is oic acid. COOR, alkoxy carbonyl or carboxy. Suffix name is alkyl O8. COX, haloformyl or halocarbonyl. Suffix name is OL halide. CONH2, carbomoyl. Suffix name is amide. CN, cyano. Suffix name is nitro, nitrile. Similarly, CHO. When CHO functional group is used as a substituent, then the prefix name is formyl or aldo. When it is used as the principal functional group, then the suffix name is all. You can see some more here. Ketone, the functional group is ketone. When it is used as the substituent, the prefix name is keto or oxo. When it is used as the principal functional group, the suffix name is one. OH, hydroxy, suffix name ol. Next, NH2, amino, amine. OR, alkoxy. There is no suffix name for this OR group because alkoxy groups are always used as the substituents only. For that reason, they do not have the suffix names. Next, C double bond C, there is no prefix name for it. Suffix name is "-ene". Carbon carbon multiple bonds, double or triple bonds, are always used as the primary suffix. Okay. Next, C triple bond C, there is no prefix name for this. The suffix name is "-ine". NO2, nitro group is always used as the substituent only. They can never be used as principal functional groups. For that reason, there is no suffix name for it. Only prefix name is there. It is nitro. Next, NO, nitroso, there is no suffix name for it. X means halogen elements, and these halogen elements are always used as the substituents only. They can never be used as the functional groups. So they have only prefix names: chloro, bromo, iodo, etc. Okay. So this is all about the seniority table for the selection of the principal functional group when a compound contains more than one functional group. Okay. Now let us explore example problems from class 10th textbook. IUPAC names, class 10th, example problems explained. Problem number 1. This is an organic compound to which we have to provide the IUPAC name, solution. In this problem, no substituents or functional groups have been attached to it. This is the only parent chain, contains 4 carbon atoms. So when 4 carbon atoms are there in the chain means the root word is but. And in this compound only carbon carbon single bonds are there. So the primary suffix is "-ane". Nature of saturation here, carbon carbon single bonds are there in the chain means it is "-ane". So the IUPAC name of this compound is but plus "-ane", butane. Next, problem number 2, solution. In this compound one double bond is there. So this is the priority for selection of parent chain and numbering the chain. Okay. So functional group has the highest precedence over double or triple bond, and in turn it has the highest precedence over substituents. Okay. Here numbering should be done in such a way that the carbon atom linking to the double bond should get the lowest number possible. Okay. For that reason, I am numbering the chain from right to left. Root word, 4 carbon atoms are there. The root word is but. Next, primary suffix. In this parent chain, one double bond is there. So here nature of saturation, carbon double bond carbon is there. So it is "-ene". Primary suffix is "-ene". And we have to indicate the number of the carbon atom to which double bond is attached. So but1-ene. The IUPAC name is but1-ene. Okay. Next, problem number 3, solution. Here to this chain one substituent chlorine atom is attached. So numbering should be done in such a way that the substituent, the carbon atom to which substituent attached should get the lowest number. For that reason, I am numbering from left to right. Root word but, 4 carbon atoms are there. Primary suffix, only carbon carbon single bonds are there in the parent chain, so it is ane. Next, there is one substituent called secondary prefix. Okay, so chlorine means chloro, secondary prefix, and the secondary prefix is attached to the second carbon atom in the chain. So 2-chlorobutane. The IUPAC name is 2-chlorobutane. Now I will explain what is locant. The number that locates the position of the substituent or multiple bond or functional group is known as locant. For example, you see here in this compound, second carbon atom is attached chlorine substituent. Okay, so here 2 is the locant. The substituent chlorine has been attached to the second carbon atom in the chain. Okay, this one is the substituent. So here the locant is 2. The number that locates the position of the substituent or multiple bond or functional group. Here substituent is there and substituent is attached to second carbon atom. So 2 is the locant here. And I will use lowest set of locants rule when more than one substituents or double bonds or functional groups are there. See here, the rule states the set of locants which when compared term by term with other locant sets, each in order of increasing magnitude, has the lowest term at the first point of difference. That means we have to number the parent chain in both ways, that is from left to right and from right to left. Okay, and we have to write the locants. Later we have to compare the locants term by term in order to know which way of numbering is correct. So you can better understand by the following example. See here. Next, problem number 4. In this organic compound, 2 substituents have been attached to the parent chain. Okay, so numbering can be done in either ways. Both ways are correct because the locants, if numbering is done from left to right, the locants are 2, 3. Suppose if the numbering is done from right to left, at that time also the locants are 2, 3. So here I have done the numbering from left to right. In this parent chain, 4 carbon atoms are there. So the root word is but. Next, primary suffix is ane because only single bonds are there. Next, secondary prefix is chloro. Okay, so here second and third carbon atoms are attached to the substituents. Okay, so 2, 3 dichlorobutane. The IUPAC name is 2, 3 dichlorobutane. Here 2, 3 are the number prefixes and di is the numerical prefix. I already explained in the IUPAC naming structure. Here we need to remember some points. When there are 2 double bonds in the molecule, the IUPAC name is alk plus adiene, alkadiene. When there are 3 double bonds in the molecule, the IUPAC name is alk plus atriene, alkatriene. Next, when there are 2 triple bonds in the molecule, the IUPAC name is alk plus adiene, alkadiene. Next, When there are three triple bonds in the molecule, the IUPAC name is alk plus a triene, alka triene. Okay, that means we have to add a to the root word. When two double bonds are there, three double bonds are there, otherwise two triple bonds are there, three triple bonds are there. Okay. Next, problem number 5. In this compound, two double bonds are there. Okay. So we have to number the parent chain. In both ways, I am numbering the parent chain, and which way of numbering is correct. In order to know that, I will use the lowest set of locants rule. Left to right 1, 2, 3, 4. Right to left 1, 2, 3, 4. Here I will use the lowest set of locants rule. Set 1 locants are from left to right. Second and third carbon atoms are bearing the double bonds. From right to left, first and second carbon atoms are bearing the double bonds. Now we have to compare these two sets of locants term by term. If you compare the first terms, at the first point of difference 1 is less than 2, then you no need to compare the remaining terms. That means numbering from right to left is the right way of numbering, whereas the numbering from left to right is the wrong way of numbering. Okay. Now, root word, 4 carbon atoms are there, it is but. Next, primary suffix, here double bonds are there, means here primary suffix is in. Okay, and there are no substituents and functional groups. So we have to indicate the position of the double bonds. So but 1 comma 2 diene. Okay, here I already told you, see here, when there are two double bonds in the molecule, the IUPAC name is alk plus a diene, alka. That is, we have to add a to buta. Buta 1 comma 2 diene. I regret to tell you one thing. In our previous videos, I used this board at several places to provide the information regarding functional groups like this. But accidentally, I typed the word prefixes instead of suffixes. Here, it should be suffixes, not prefixes. Okay, so this is the typing error. You please try to correct it. I request you all, please read it as suffixes, not prefixes. Okay. Next, problem number 6. Solution. In this example, alcohol functional group is there. Okay. Now we have to number the carbon chain in such a way that the carbon atom linking to the functional group should get the lowest number. For that reason, I am numbering the chain from starting from right to left. Okay. Functional groups. While numbering the parent chain, the carbon atom attached to the functional group should be given the highest priority in numbering. Okay. So for that reason, I am numbering from right to left. Now, root word, 4 carbon atoms are there in this compound. So root word is but. Next, primary suffix is an because only single bonds are there. And coming to the secondary suffix, you see here, OH functional group is there. So the functional groups are represented by secondary suffixes. So here alcohol functional group is there. The secondary suffix for it is ol. Okay, you see here ol. IUPAC name butane 1-ol. The terminal E of ane, ene and ine is dropped. This E is dropped when it is followed by the suffix beginning with A, I, O, U, or Y. For that reason, the terminal E from the primary suffix is dropped. Butane, E is not there here, 1-ol. Okay. Next, problem number 7, solution. In this aldehyde functional group, CHO functional group is there and it is one of the chain terminating functional groups. See here, these are the chain terminating functional groups. When a chain terminating group such as shown above is present as the functional group, it must be assigned number 1. That means the carbon atom in that functional group must be included in the parent chain and assigned serial number 1 while numbering the parent chain. So 1, 2, 3, 4. Root word, 4 carbon atoms are there, so it is but. Next, primary suffix, only single bonds are there here, so it is ane. Next, secondary suffix you see here all. For CHO functional group, the secondary suffix is all, Al. Okay, so the name of this compound is butanol. You no need to write butane 1-ol because already serial number 1 is given to the carbon atom present in the functional group. So it is butanol. Next, problem number 8. It is similar to the above example only. COOH functional group is there, that is carboxylic acid's functional group. The secondary suffix for that is oic acid, and COOH is also one of the chain terminating functional group. See here the same way. So the carbon atom in that functional group should be included in the parent chain and it must be numbered 1. Okay. Now 4 carbon atoms are there, so the root word is but. Next, primary suffix is ane because only carbon single bonds are there, so it is ane. Next, secondary suffix you can see here, carboxylic acids COOH functional group means it is oic acid. So the name of this organic compound is butanoic acid. Butanoic acid. Here also E from ANE has been dropped because it is followed by the suffix starting with O. Okay. Next, problem number 9, solution. See here. Here carbon atoms are forming a ring. So this is an alicyclic compound. So numbering can be done from anywhere. Okay. So the root word in this ring 4 carbon atoms are there. So the root word is but. Next, primary suffix you can see here, primary suffix only carbon single bonds are there. So the primary suffix is ane. Next, primary prefix, no substituents or functional groups present in this compound. Here primary prefix cyclo is used. When carbon atoms are forming a ring, then we have to use one primary prefix named cyclo. So the primary prefix is cyclo. So the name of this compound is cyclobutane. Next, problem number 10. Solution, you see here. In this compound, alicyclic compound, carbon atoms are forming a ring here. It is an alicyclic compound. Okay. So in alicyclic compound here, 4 carbon atoms are forming the ring, and 2 substituents bromine atoms are attached to the 2 carbon atoms here, and we have to number the ring in such a way that the substituents should get the carbon atoms attached to the substituents should get the lowest numbers possible. Okay, so for that reason I am numbering from starting from here in clockwise direction, or you can number the ring starting from this carbon atom in anti-clockwise direction also. So the root word is 4 carbon atoms are there in the ring, so it is but. Next, primary suffix, only carbon single bonds are there, so it is ane. Next, primary prefix, because carbon atoms are forming the ring, so it is primary prefix is cyclo. Next, secondary prefix is bromo. Substituents are called secondary prefixes halides. So the name of this alicyclic organic compound is 1,2 dibromo 1,2 cyclobutane. Next, problem number 11. This is an organic compound containing ketone functional group. You see here the carbon atom in the ketone functional group is the part of the parent chain only. Okay, and we have to give the numbering to the chain in such a way that the carbon atom attached to the functional group should get the lowest possible number. For that reason, I am numbering the parent chain from left to right. See here, the name of the functional group present in this compound is ketone. C double bond O. Okay. Numbering is done from left to right so that the carbon atom attached to the functional group will get the lowest possible number. Next, root word, 5 carbon atoms are there, so the root word is pent. Next, suffix, primary suffix, only carbon single bonds are there in the parent chain, so the primary suffix is ane. Next, secondary suffix, you can see here ketone functional group means it is represented by the secondary suffix one, one, one. So the name of this compound is pentane 2-one. Pentane 2-one. See here, E from the primary suffix, E from ane, that is primary suffix, is dropped because it is followed by a suffix beginning with O. Okay, so this is the IUPAC name of this compound. Next, problem number 12. See here, this is an organic compound containing CHO functional group, one of the chain terminating functional group. When a compound contains the chain terminating functional group, at that time the carbon atom in it must be included in the parent chain and it must be assigned number 1 while numbering the parent chain. So for that reason, see here, chain terminating functional group CHO is one of that. So 1, 2, 3 like this. So the root word is 3 carbon atoms are there in the chain. It is prop, and primary suffix is n, secondary suffix is, see here, CHO means all, AL, all. Next, secondary prefix, that is substituents, chloro. So 2 comma 3 dichloropropanol. 2 comma 3 dichloropropanol. E is dropped again here. Okay. Next, problem number 13. Solution. In this compound, one double bond is there and one triple bond is there. When multiple bonds are present in a compound without functional groups, we have to number the parent chain in such a way that multiple bonds, that is the carbon atoms bearing the multiple bonds, should get the lowest numbers possible. So I will number the parent chain from left to right and from right to left also. Which way of numbering is correct? In order to know that, I will use the lowest set of locants rule. So here I am numbering the chain from left to right and from right to left also. Let us use the lowest set of locants rule. Set 1, left to right, the locants are 2 comma 4, that is the second and the fourth carbon atoms are bearing the multiple bonds. Next, set 2, right to left locants are 1 comma 3, that is 1 and 3. These carbon atoms are bearing the multiple bonds. So which way of numbering is correct? In order to know that, we have to compare these two sets term by term. See here, I am comparing the first terms. At the first point of difference, 1 is less than 2. Then you no need to compare the remaining terms. So when 1 is less than 2, that means the numbering from right to left is the correct way of numbering, and from left to right is the wrong way of numbering. Okay. Then root word, 5 carbon atoms are there, so it is pent. Next, primary suffix here, in and ein, because double bond is there, it is in, triple bond is there, it is ein. And while writing the primary suffixes in IUPAC name, we have to follow the alphabetical order. So in comes first, then ein. So pent 3 in 1 ein, the IUPAC name. Pent 3 in 1 ein. We should not add a, penta. Don't write penta here. It is not alkadiene. Okay. So pent 3 in 1 ein. Next, problem number 14. In this compound, OH functional groups are present. Same functional group is repeated twice. Okay. And we have to number the parent chain. Which way of the numbering is correct? To know that, we have to use the lowest set of locants rule. So first I am numbering the chain from left to right, then from right to left. So lowest set of locants rule I am using here. Set 1 locants left to right. See here, third carbon atom and the fourth carbon atom, these two carbon atoms are bearing the functional groups, OH functional groups. So left to right locants are 3 comma 4. From right to left locants are, you see here, first carbon atom and the second carbon atom are bearing the functional groups. Now we have to compare these two sets of locants. First, let us compare the first terms. 1 is less than 3, then you no need to compare the remaining terms. So at the first point of difference, 1 is less than 3. So the numbering from right to left is the correct way of numbering, whereas the left to right is the wrong way of numbering. Okay. So here the root word is but. Primary suffix only, single bonds are there, carbon carbon single bonds are there in the parent chain, so it is ane. Secondary suffix you can see here, OH functional group means ol. Okay, so here alcohol functional group is repeated twice. The name of this compound is butane 1 comma 2 diol. Butane 1 comma 2 diol. Here E from the primary suffix is not dropped. Why? Because it is followed by the suffix D. If it is followed by the suffix A, E, I, U or Y, then only E should be dropped. Okay. Next, problem number 15. This one is the last problem in this video. Solution. In this compound, no functional groups are there, but substituents have been attached to the parent chain. So this one is the parent chain I am selecting, and we have to number the parent chain in such a way that the substituents attached to the carbon atoms should get the lowest possible numbers. So I will number the parent chain from left to right and from right to left also. Later I will check which way of the numbering is correct by using the lowest set of locants rule. So numbering from left to right, then from right to left, use the lowest set of locants rule. Set 1 left to right locants are 2 comma 5 comma 5, that is the fifth carbon atom is attached to methyl groups. For that reason this locant is repeated 5 comma 5. Next, from right to left locants are 2 comma 2 5. Now we have to compare these two sets of locants term by term. The first terms are equal, then compare the next terms. So 2 is less than 5. So at the first point of difference 2 is less than 5, then you no need to compare the remaining terms. That means the numbering from left to right is the wrong way of numbering, and the numbering from right to left is the correct way of numbering. Okay. So root word 6 carbon atoms are there, so it is hex. Primary suffix only carbon carbon single bonds are there in the parent chain, so it is ane. Next, methyl groups, these are the substituents or secondary prefixes. So the name of this compound is, see here, 2 comma 2 comma 5 trimethyl hexane. 2 comma 2 comma 5 trimethyl hexane. Okay, so that's all for this video. In the upcoming video, some problems given under the exercise in the textbook will be taken up. Thank you. Keep watching.